could you design that
Yeah.
the normal way?
No.
How long would it take? I mean, it's just
Years.
Yeah.
Would be years. And this is probably the generative portion of this is probably a couple of days for me, I would say. And then, I mean, creating the kinematic model was probably longer. A lot of it is just learning how to do it.
Hey everybody, I'm Jonathan Odom, maker, inventor, designer, and Autodesker. Welcome to Shop Talk, the podcast series where we talk to makers, inventors, designers, and engineers from shop to shop. Today, I've got Kaching Song with me because I don't know anything about cars, and he does.
And I love cars.
Yeah.
It's great to be able to co-host with Jonathan on this episode. We've got a awesome guest. He is a 4-time King of the Mountain Pikes Peak winner. He's also a very knowledgeable engineer, quite talented in his content, even when all the stuff that he's put out. And he's just all around innovator, using all kinds of different tools to build his race cars. Robin Shute, welcome to the show.
Hello, and thank you for having me. Absolute pleasure to be here.
Can you share a little bit about your background and how did you get to where you are today? How did you become King of the Mountain 4 times?
That's a very long answer. I'll do my best to keep it short and sweet and concise. But I will do an origin story. I grew up in the United Kingdom, hence the accent. East side of the UK, in a little known county called Norfolk, and that county is actually pretty renowned for a car company called Lotus Cars. And along with that, there's a very small but burgeoning racing industry over there. So that's in my blood, my heritage. And my father worked for Lotus, and he was what I call one of the founding fathers of the Lotus Elise. So one of those kind of 3 key people who really started that project in the mid-90s. And I was about 7 years old then, watching this car be created. It was an amazing experience, and I think really set up, my passions and where I wanted to go in life, let's say. As part of that, my dad actually hill climbed in the UK. So I was a little kid going around the country with him as he competed. The hills over there are a little different. Most runs are about somewhere between 30 seconds and a minute. You're maybe gaining, let's say, 100, 200 feet in elevation, nothing like Pikes Peak, which we'll get to down the line. But basically that set me up for, a passion for cars, a passion for engineering, passion for driving as well. That all came there. And I've just ridden that wave since. So I went to school for automotive engineering, basically. And at the time, there was this little known car company called Tesla Motors. That was just getting going in Silicon Valley. And that very first Tesla car, if you recall, is actually a Lotus underneath. There's a Lotus orbiting Mars at the moment. So that's based on the Lotus Elise platform. Wow. So when that company really started to grow, it took a lot of Lotus engineers with it. And part of that and networking, I was able to interview and get a job there. So fresh out of school, I started working at Tesla Motors in California, and was a chassis suspension design engineer, as part of that. And on the side, I decided to buy a race car, and with some of the friends at Tesla, started to go racing. And I'm kind of a DIY. I like to do it myself. So I love building, prepping the cars and all that, and that's how we did it. And, I've also been on the side, I've been racing something pretty much all my life. It was RC cars to start with when I was 8. And then it went to go-karts, and then I did alpine ski racing for a bit, and then back to cars again. So I've always been incredibly competitive, and I found myself racing open wheel cars in the West Coast and been rather successful at it. And I kind of decided on that. I never intended to do it for long. I just wanted to do it because I love it. But it was like, do you know what? I'll continue until I run out of talent or money. Which is normally what happens with motorsport, isn't it? Let's be honest. But actually just proved to be rather successful, and kind of weaved my way through and found my niche and where I could specialize from the racing side of things. And then from the professional side of things, I sort of continued on. So it was first of all Tesla Motors. I then went over to Faraday Future. And from there, I expanded over to Special Projects, which was much more focused on full vehicle design and also motorsports as well. Two of my huge passions. I did that for a couple of years. And that's where sort of this next phase of getting to Pikes Peak comes along. So at that point, I was racing internationally a little bit. So I had my international racing license, and also an engineer there. And they wanted to go and take the FF91, which was this 2.5-ton electric SUV, luxury SUV, up to Pikes Peak as a testing exercise. And they said to me, we need to put the entry in, and we need to have a driver nominated. Now, we know you're racing and you have an international license, so you're probably eligible. But at the time, they had a Formula E team, so their plan was to pull in a Formula E driver to actually do the driving, but they needed a name on the entry. But just as luck would have it, that partnership with that Formula E team fell through, and I ended up being the driver for that race. Went very well, very successful. I felt very much at home with it, and absolutely just caught the bug. This is what I wanted to do. So after the race was done, I was basically, that was the year that Volkswagen turned up with the IDR. Okay. Now, Pikes Peak itself, as a bit of context for viewers who maybe don't know the race, it's probably the world's most incredible hill climb. Starts off at 9,500 feet and races all the way up to 14,000 foot summit of one of the biggest mountains in Colorado. The road used to be dirt. Now it's all paved, and it's this snaking road up the side of the mountain, incredibly exposed, 156 turns. The other neat thing about it is there's very few rules for cars, so you can be incredibly creative with the design engineering of the vehicle as well. And you have this challenge of getting up this mountain and dealing with the thin atmosphere. It's very rare you have to deal with that in any other racing series. And this challenge is unique because of the altitude climb. It's more like a plane than it is, I say this car will be able to climb faster than a Cessna and go faster than a Cessna, higher than a Cessna. This is doing plane stuff basically. So very, very, very different to what we'd see, say, in Formula One or endurance race, something like that. So Pikes Peak for me, really tickled the driving side of things, which I'd say is more of a style of rallying, but with the speeds of, up to Formula One. Yeah. And then it also has the engineering.
There's just so much to talk about here. First question is, given that you can't test the car on the track in the off time, how important is simulation to you? You obviously have to be prototyping and trying everything you possibly can before sending the car up to the mountain, right?
Exactly. So simulation is very important. There is sort of two aspects to this. The first one is essentially the simulation of what's fast on the mountain is not what's fast on a regular racetrack. So you have to understand there's a different mix of weight, tires, downforce, power that's going to work up there versus on a circuit. So that's like an upfront understanding of what it takes to make a fast car. That kind of simulation, I've done some kind of first order, maybe a little bit into the second order, like lap sim models, and understanding some sensitivities around that. So it understands, okay, well, if I add 1 kilo of weight to the car, it's going to go 0.3 of a second slower up the mountain. I have that kind of sensitivity. So when I'm designing parts and understanding compromise, I can make an informed choice.
Sure.
So that's that first one. And then the second bit, which is less so for the mountain per se, but just designing a race car in general, you get such little running of a car, and it's expensive as well. So you can't just keep running around doing laps and laps and laps and turning up to the track each day to check parts are going to be okay. You need to know upfront, is the design pretty good? And that's where, when I'm designing, simulation comes in the form of CFD for the aerodynamics of the car. It comes in the form of FEA, finite element analysis, to make sure the parts are strong enough. And then, I almost say, like, I can't be bothered with FEA anymore, because I'll just go and do it in generative design, because that's part and parcel of that workflow, is just going straight into calculating the loads. That's through some things like suspension kinematic software, some spreadsheets and all things like that, to go and essentially create the loads. I can pop into a generative design study and create the part. That's by far the quickest for anything that's complicated. I still find if we're doing like a basic clevis or something like that for a rod end, it's a little bit quicker to just sketch it up as a regular parametric model and then run that in the FEA and see what I got.
Sure,
But otherwise, any of these like complicated suspension parts, then it's so much quicker to do that in generative design.
When did you start getting into generative design, or like how did you start picking that up and realizing like that was the direction you wanted to take?
So that was at Faraday Future Special Projects. Because part of what I was doing there was trying to look for the future for some tools that could help go and design cars. And I'd been aware of some like software. We used OptiStrut at Tesla to try and optimize some wheels. That was quite interesting, seeing how that would shape and form the part. But it was very clunky. It was very hard to put that into the workflow. You had to take it away, do it, it would come back, and it didn't really give you anything useful. It just gave you clues of what to do next, which is almost as good as like the preview on generative design, being honest. But I know if you use that well and you put that into a company that's using this regularly, you can get very good outcomes from that. And I'm sure you can now, but I'm a big proponent. I think as engineering and technology and all that has improved, the outcomes and the complexity has just got a lot worse. Go and look at what they were doing in the 50s and 60s in aviation. Same in Formula One, 60s, 70s, 80s. They could create whole vehicles with a very small team very quickly and iterate and improve far quicker than we can today. Now, today, everything's a lot more optimized and complicated, let's say, but that's because I think we create systems to be a bit like that. It's a sort of a self-serving thing. A company will always want to get bigger and bigger and bigger and more complex, and it becomes hard to innovate. So I was really looking for software that could remove people out of the workflow and have people be a lot more self-sufficient, because there's always every engineer apart design goes through, you kind of have a step of inefficiency of that communication. So if you can have a single user have all the design tools at their fingertips to go from literally a SketchUp through to a complete tested part within FEA, that's so powerful. And back then, when I was first using Fusion, I was so surprised at how essentially 3D modeling was completely different. It was more like sketching and more like dragging and moving. And, I thought it was genius to go and give the software out and not capture design history as a default, because that's a completely different way of modeling at the time of, using CATIA V5, V6, SolidWorks. That's never how you default do that. And that, I think that helped me understand this is more of a creator's tool than it is just a hardcore engineering tool. That's maybe a better way to be thinking about designing parts anyway, if you really intend on making them, right? And I think that's key to creating that short workflow and that efficient engineering in any business, whether it's like small business or big business. You should be working and looking to go and do that. So that was a bit of that. And then the generative stuff, I was just aware of, like, the mathematics are there to go and through the FEA to like go and know what the part needs to be. It seems silly. I'm going and designing and refining part designs when it's like, this is essentially an algorithm, what I'm doing.
Yeah.
At a way of doing it. And that was when, Fusion came along with this generative product.
Yeah.
And it's fascinating to go and try out and see. And it's, I could see back then as it is now, it requires a good level of engineering to go and do it because you need the loads up front. And that's something that I don't think many people do, honestly, to go and calculate that, figure out what that is, and then put that into a part. But you can, I think, from first principles, go and do some rules of thumb of, how is this being used? What's going to be the worst case for it? How much is that roughly? And then check your theory and see what comes out in the way of a part and benchmark it to stuff that's already been. And I think you get a pretty good feel for if it's on the right track or not.
I'm curious about generative fluids. Have you tried that?
I haven't yet. I keep wanting to go and do that. I've got the oil pickup for the oil tank, which goes to the engine. I need to do it. I've got a few places where we need to do it. Yeah.
I mean, you did that intake plenum with metal additive, right? And like, it just made me think, there's got to be some other opportunities for that. If you're already used to that tech.
Yeah. The intake is a nightmare. I did go and look at this.
Yeah.
Intake is tricky because there's so much transient with it. So you've got valves opening and closing, there's pressure waves, shock waves, all that good stuff. So I think the fluids would do really well for a general flow path. I have some bends going from the turbo compressor outlet to the intercooler, and then from the intercooler into the plenum, and probably the intercooler intakes. I will definitely use it there. That's where you want it, because that's a lot more of a steady state flow. That's got all these bends to go through and some tight spots to go through as well. So similar to design space with the generative structural stuff, I've got a problem there where I want a really straight fluid flow from one outlet to another, and it's going through a really awkward area, and I don't know what's best, and I want to let the software decide that for me. So that's an exciting part. That's in the next couple of weeks I'm going to go and do. Nice. And a lot of the oil flow lines, the coolant lines as well, you can do that. I mean, when you're making these parts, even things like coolant lines, it's better and cheaper to print an aluminium part. Go and do that. Like, plumbing a race car it's like most of race car building. It's incredibly expensive. It's something that everyone takes for granted, and it's hard because you think joining tubes together is simple. It's really not. When you've got to fit around all this other stuff and not get hot, and all these constraints you're actually fighting with, something that seems so simple becomes complicated. So any of these times, like for me, I can't just attach like point A to point B. That's not good enough. It's got to be perfect. So with my OCD, the generative stuff is great because I can put that to ease and rest because it's the best solution, and does it all for you. So that's brilliant. You just got to think about it differently when you get going with the problem.
Yeah, I was gonna say you're saying that's hard because you're doing it the right way, right? Like there are people that are building race cars that they're just gonna break down after a while, after a few laps. So I think that's why you're coming up on top, because you're doing it the right way. You do the engineering.
I always think you're like eliminating the stuff you then have to develop down the line because you've put a bit of development to it up front.
Sure. Yeah.
Just like, I was just trying to do this to this, and it seemed to be the best way to achieve that outcome, and I didn't think to go into it in any more depth. And then you run your car, it overheats, and you're like, it turns out it was the wrong size pipe, or there's this huge restriction on this bend, or there was too many joints together, and now it's leaking. There is it's the oversights that bite you in the butt. And if you can put a little bit of thought and care into each part, you're gonna have a much higher success rate overall. And then when you're using generative design, the part is already designed in FEA. You've already thought about some loads, so you've got a pretty good idea of it. Same with the fluid flows and all this. It front loads quality that then you can benefit from down the line.
Yeah, I've got a new quote: reduce oversight and add foresight. There you go. Reduce oversight, add foresight.
That's good.
Yeah.
That could be one of those inspirational posters.
We should make a shirt out of that. That would be
nice. With a cat. Is that the cat hanging?
Yes, cat hanging. That's exactly, the one. Exactly. I was trying to remember which one that should be.
I love it. Okay, Robin, I have let's go back to a previous topic you touched on, which is you made like a quick comparison between like racing on the track versus doing hill climbs, okay? And obviously very different skills and also very different environments. Why you also touched on a bit of why you're drawn to hill climbs. Do you like the danger? Does that draw you in?
I always tell people I'm a bit of a scaredy cat at heart. Like truly I am,
Yeah.
but I do love a good challenge.
Okay, yeah.
And I think what draws me to the mountain is more the fact that it's a really worthy challenge to go and do because it's hard in a lot of different ways. And the amount I've grown as a human to go and do that race it's like I think that's what brings me back each time. When you're going up there flat out, you're a little busy, so there's not much time to be scared. You're busy getting stuff done. But there's definitely scary moments around it, and it's a whole like a risk mitigation type exercise where you don't want to be putting yourself in too much exposure, to risk all the way through because we're there for. We're pretty much there for a month, and there's essentially 10 days of running on the mountain. So what the last day is the race, but you got 9 days of testing beforehand. So you are getting a little bit of practice there, and it's just a gradual build. You have to keep building up, and I'd say it's like probably if you truly want to be competitive, it's like 70% science project and 30% driving.
Okay.
That's probably the ratio, somewhere between 50-50 and 70-30, depending on the year. You probably want like a 70-30, 80-20 science project first year and like a 50-50 driving science project year next year. That's probably like the best way to do a car up there. So it's it is fun, like doing something a little dangerous and getting away with it. But yeah, you can't keep doing that.
I have another question for you about Sendy Club. Why is Sendy Club called the Sendy Club?
So go back in the story I told previously when we decided to, do it alone and go and figure out the best way or the way to go the fastest we can with the resource we had.
Yeah.
And we realized we were going to buy a secondhand car, a used car, race car, of course, and then go and hot rod that basically for the mountain. That was the plan. So then we went on a tour of the country. We looked at a couple of different cars to go and see if that would fit the bill. And one of them was over it's actually Canada, in Nova Scotia, Halifax, where they had the Wolf basically. And when we were there, that's a little way to get there. It's out of the way and the other side of the country. So you stay a couple of days. We were at a brewery and sitting down being like, what we're doing here is quite big. And although we've got no real intent of monetizing this, we're doing it just because we probably should brand ourselves somehow. And that's where we come up to, we're just like, well, we don't really have a good idea, but
Yeah.
kind of sending it, but this like we're not being dumb here. It's just like a little sendy, not full send.
Okay.
I mean, people could argue it was dumb. But yeah, that's kind of how it came about. So we're like, place will call ourselves, brand ourselves the Sendy Club, and
Love
if we
it.
think something better, then
That's a good name. Yeah, I dig it.
Yeah, I mean, are you collaborating on Fusion with any of these people at all, or is that?
Yeah, Fusion's been absolutely amazing for that collaboration, mostly because like it's so easy to share the files with everyone, and we've got a shared product file. People can jump in and have a look at stuff and design when they can. I mean, the entry level like is free, right? So if people just want to see and look at stuff, they can be part of it and get a little involved. Which is also fantastic as well. But the file sharing is another like no-brainer. I'd been working previously with like Anovia with Katia, which was the worst, clunkiest. I spent all day opening CAD files.
Yeah.
And it didn't help. Whereas I think Fusion does really well with focuses first of all on collaboration and then has a little bit of change control in it now. I haven't started using that truly, but I think it's if I really cared enough, I could use that tool well. But just like most good engineers, they really don't clean or neat CAD models or file organizations. They're busy making stuff.
Yeah.
And I think you can do that, have that really disorganized approach and still have a good outcome. And you can also, if you need to, go and be a little more organized and get an even better outcome with it. So yeah, just the cloud base is, it's just for me as well. I do it on my Mac, this computer. I'm designing when I'm traveling and things like that. I want to collaborate, and I have on my desktop. So it's all, even between those two machines, is amazing.
Yeah.
That's great. Yeah.
That's what I want to hear, man. And I totally agree. It's the idea that you can do it painstakingly, perfectly, get every reference right in the right spot. Everything's super clean and it works. But another great thing about Fusion is you can just kind of slap a bunch of stuff together and, quickly make something happen, and it still works.
Especially in direct. Yeah.
Yeah.
Doing direct modeling.
Yeah. Like you're just, faster to your result.
It's just so much easier. And then the tools you do have, like T-splines is another one. Oh my God.
Yeah.
Have you played with that much?
Oh, the whole car's been designed on the ergonomic surfaces, and I use another CFD tool, which similar guys, I think, to you guys, in that it's not designed to be perfect, but it's aimed to be quick and iterative. And so most CFD need a solid model to go and run the simulation, whereas this and its software, it essentially creates a model afterwards, but you can do it with surfaces. So you go and combine T-splines with that, that ability to mesh, and that's all done online as well. And I can access that everywhere. I can go and do aerodynamic modeling, and have good control over it. And I get really both beautiful forms as well as aerodynamically efficient ones. I have that level of control. So yeah, it's just another thing where, trying to think how many CFD runs is in this car. It's hundreds of runs.
So speaking of the car, you had shown us a few parts before we started recording here. Do you want to show us around, or what have you got in front of you?
Here's what I made earlier.
Yes.
Look at that.
So it's a rear suspension upright. So this is perfect for generative design because it's doing a lot of functions all in one. It's holding a brake caliper onto it, and it's also got essentially 3 suspension links going to it, and it has to have a wheel bearing, obviously, for the wheel. And then a few other things, a few other mounts for wheel speed sensor, boss, and then some mounts for brake ducts. So this lends itself so well to generative because, when you design a car properly, you've got to design what's called the kinematics, which is where the suspension points are. Oh. If you've got a software to do that well, you are able to calculate loads. It's reasonably easy to calculate, pretty precisely the load at a tire, and then put that into the kinematic model and spit out the loads for this. So this is how you end up with this. Could you design that?
Yeah.
No.
How long would it take? I mean, it's just
years.
Yeah.
Years. And this is probably the generative portion of this is probably a couple of days for me, I would say. And then, creating a kinematic model was probably longer. A lot of it is just learning how to do it. Yeah. Learning how to use the software to do it. It's definitely a bit of an art form using that, which is fine. But once you kind of figure it out, you learn how to kind of get it to do what you would like. Let's say.
Yeah, almost like give it prompts, right? It's a way of giving it prompts, except you're just trying trying to pinpoint the locations you want to stay, and then the things that you can let it calculate. Yeah,
exactly.
That's one of the most complex generative parts I've ever seen a customer do. I think
complex.
There's a lot going on there.
Yeah, there's a lot going on there, and you wouldn't when you look at it having it been generated, you can understand where all the load's going, but I wouldn't have thought to shape it like that to start with. That one's pretty busy, and again, that was CNC-machined. That wasn't even printed.
Oh wow!
Yeah, so that's CNC'd. So I used the 5-axis.
Did you do that in house?
No. That went to Xometry. Did that one?
Okay. Yeah.
Great.
Good.
Great choice.
They do it right every time.
Yeah.
Love Xometry.
I didn't know it was CNC'd. I thoued it was printed because that's usually how.
Yeah. So one of the things they did mess up a little bit was the anodizing. So now it looks 3D printed. So I was like, no, it's not. It's just anodizing.
It's so much more impressive as a 5-axis part.
That is cool.
Exactly. But this part here, so this is the steering arm. So this is essentially here. This is what we call camber shims, and you adjust this distance between. This is where the upper arm comes in. So this one's printed in titanium. So
wow.
There's a printed part on there as well. But yeah,
that is cool.
Gorgeous.
It's beautiful.
Yeah.
Why do you think being in the kind of the racing world, why doesn't every team start to do this? Is it just awareness or expertise? Like,
yeah, I think it's both those things. When you go and look in the racing world, most of it now is like spec formula stuff, GT3 stuff, so factory cars. So there isn't the level of design and engineering in the sport now that there used to be. Like 10, 20 years ago, it was everywhere. Even in like Southern California, Dan Gurney, Swift, all this stuff. There are race car makers here as well, and that's kind of gone. It's like most industries, you got some big players in like Dallara and all that doing most of this engineering for these spec cars. So that's, I think, made it a bit more of an uphill battle from like a demand aspect. And then on the other side of things, it requires a reasonable, like, you need to understand how forces work, how some materials work. Just have it like you don't need to know a lot. You just need to know a little bit to understand, like, and it's a good amount of knowledge to have anyway if you're designing stuff. You need that prerequisite to really do well with this. And then the next thing, because it's not common, and it does such a good job, it is like this is too good to be true. Like the most common question I get asked is, how are you going to validate the part? Digitally. I'm like, well, no, that's how it's made. It's been a fully validated FEA part, and you can export the study and run it in FEA if you need a bit more control of meshing, and it's always there. It's never not there. What it said it was supposed to do in the first place. So I think it is a bit of a mindset and understanding. So, but what I am seeing with the 3D printing now, the metal 3D printing as well as plastic, people are going back to that, and you're seeing people starting to cotton on to it and being creative again. And you see it in like cooling routing and stuff like that, which isn't really regulated for a lot of the spec cars, so they can go and do their own solutions there. So it is starting to come. It's a scary looking thing, when you look at it. You look at this titanium steering arm here. You got this like tiny guy there, and they're like, that's not doing anything. It's not doing much, but it is doing something, and that is part of the whole system of what it needs. So it's people understanding why it's there and whether to trust it or not. And the same as the printed parts. 3D printing is metals is still, it's not a guaranteed science, but it's pretty darn close. And you go and design around some bigger factor of safeties, and you're okay.
Yeah. So Robin, we know that you're in the shop, so let's take a look at your shop and then give us a quick tour of what's going on here.
Sounds good. We got the phone cam. What we have, this is Sendicar, and this is on its build table right now. I am here at Mountain USA, Carson, California. These guys are engine builders. We have a full engine dyno over here.
Is that a Ferrari?
It's not a Ferrari. Get out of
here. I thought I saw a Ferrari.
Oh no,
the reason Kaching is here, by the way, among other reasons, is that he knows about cars and I clearly do not.
I opened my jaw dropped because I saw I believe I saw a Acura Type S, Integra Type S in the back, which I'm actually
you were just talking about that
in the market for one. So
this one might be for sale in a bit.
Interesting.
So back here, this is their TC car. It's HRC, so Honda Racing.
Yes.
The TC Acura. So this is in for a little bit of gearbox work. They have a Quaife transmission sequential in this, and
this is the one they took to Pikes Peak. No,
this isn't that.
Oh, okay.
This is Similar though. So fun story about all that program and the Wolf. So Aaron Hale worked at HPD, which is now HRC. He was our engine guy for the Honda K20 in the Wolf. So he's helped us both with that program, and then the Acura is going to Pikes Peak. And he's, I think, the most winningest person on the team at Pikes Peak that I can think of. He's got like 7 overall wins under his belt. He also did Romain Dumas's wins as well when he had the K20 in his Norma. So yeah, that's that guy.
Awesome. Okay, enough about that. Let's look at what you're what you're showing us.
So this is the workshop. It's absolutely fantastic place to work out of. I've got manual mills, manual lathe as well, a little tabletop one there, belt sanders, all this. This is the stuff you need really to do, finish parts and get, a car built up, because it never quite goes together as you'd hope. Sure. This is Sandy car on the build table, as I said. We're in a point, it's not far off being able to go on the ground, actually. We've got the arms hanging off now. Front suspension is pretty much built up. This engine is a mock-up engine, so it hasn't got the parts in it just yet, but the engine is semi-stressed as part of the structure of the car. So the car couldn't be pulled together unless the engine was here. So that's why that's there.
More generative brackets there.
Yeah.
That's it. I think this is my favorite generative piece, and that's the bell housing. This is also 3D printed. So this attaches the front of the car to the back of the car, basically. And we've got within that a turbo that lives there. It's tucked in there incredibly tightly. So this bracket is suspension mounting points, structure, also the clutch, all that goes within there. Turbo mount as well. It's doing so many different functions in one part. I think it's around 5 kilo overall. It's taking tons of load. We've got another neat bracket here. This is the...
Oh, yeah, I've seen that on IG, on Instagram.
Yeah, that's it. That one's actually CNC'd. It was cheaper to CNC, so that's what I did. That's, again, holding the engine to the back of the tub, and also these steel frame parts as well, which also... these are mainly there for structural rigidity. This creates a box, a stiff box to stop the car twisting structurally, as well as these big pieces here. There's another bit of structure and printed parts. The top trunnions. You've got push rod rockers here as well. So this does the suspension. These rods are where the spring and damper goes. This is the tailpipe. This is printed out of Inconel. It's like 0.8 of a mil thick, I believe.
Oh.
My God, that's crazy.
Yeah.
Is that just to get weight down? Why is it so thin?
Yeah, you don't want a heavy part. And also, when you print parts, you're charged based on the material you use. So it benefits you financially to optimize the part better. So it's a good feedback loop, let's say.
That's the foresight. There you go. That's the foresight coming into play.
Got to be lighter. Got to be a higher performance.
Did you do the carbon fiber in house?
This tub is the only carryover part on the car. It's a Tatus F4 tub.
Oh, okay.
Yeah. So that was a pre-existing part, but then everything else in the car you're seeing is designed and made by myself. So this is all FIA crash approved. That's one of the big reasons for it. It's all been crash tested and has got these like side intrusion panels and all that good stuff. But we've had to modify it a bit to get this cage on. So this cage requires these aluminium inserts, aluminum inserts. You can see one over here. So they get basically cut. You cut the tub and then bond this aluminium piece into there to provide the structural landing, and that bridges over. I've got one. It's one of the inserts here. It bridges over the two. Carbon fiber is like a sandwich construction, 2 skins, and then a sandwich layer between, and that's what gets bonded in there, basically. Again, printed. That's like, I don't know, $40.
Nice.
Love it.
Yeah. So front here is all the suspension. We've got full upright built up here. You can see you've got like the trigger wheel for the ABS, all these different clevises. That's printed titanium. This is CNC 7075 5-axis generative design. We've got another generative design steering arm in tie.
That's beautiful. Wow.
Yeah, brake calipers. Yeah.
What calipers are you running there?
These are Alcons. Alcon, well, thank
Alcons,
you for
yep.
that.
Yep.
Alcon calipers. These are off of a Super Formula car.
Yeah.
Originally, so it's like the Japanese Premier Single Seater series, and that's the same as the Yokohama tires I run. Also, Super Formula tires. That class of car is pretty neat because they're lighter than F1 and still have good downforce and good grip. So they're like through the corners, they're about as fast as F1. They're just a little down on power. They're about 600 horsepower with what they have. So this will be lighter than the Super Formula, has the same tire, more downforce, and close to F1 power, be about 850, 900 horsepower. So
Incredible.
yeah, it's going to be quick. I'm going to have to go to the gym. Yeah, so that's it.
Great.
Anything else you want to see in the shop? This is a little Lotus 7. This is Ken's car, the founder. It's very lightweight. I can pretty much pick up the back and drag it around if I needed to. I go here. You can see that. It's around. Probably doesn't come out on camera. But yeah, this thing, I don't know, is 800 pounds, 900 pounds.
Wow.
Yeah.
What is that? In a 4-cylinder?
Yeah, baby little.
That's all you need when it's that light.
Yeah.
Cosworth,
Yeah.
With ITBs.
Very cool.
Carbs, Webers. So this is how engines used to be made. You can see here the inlets and the exhaust are on the same side. It's cross-flow head.
Oh yeah.
Oh, sorry, not cross-flow head. The opposite. That's where they went to after that. Then it was called cross-flow. Don't know what you call that, but it seems archaic now. But yeah, no, it's a time of yesteryear. I want to get a hat made. I think make race cars light again. That's my
there you go. Yes.
philosophy for another one you could coin.
Love it.
Yeah. All right.
Very cool,
Thanks
man.
for the tour.
Thanks
Yeah,
for the
that was
tour.
awesome. Well, Robin, I have another question for you that's more to the content that you put out. You put out videos of essentially you explaining in very detail the whole engineering background and like deep dive into how you develop certain parts, the FEA analysis, the aerodynamic of some of the parts that you're making. And these were like half an hour, half an hour, maybe 40 minutes long. And you've got people in the comments just being like, yo, this guy, like, I watched the whole thing. They found it super valuable. There's one specific comments like, oh, someone actually doing engineering, to showing actual engineering to car development. So refreshing. Why do you feel like, why do you put these videos up and share it with the community? Why do you do it?
It's a really good question. Why am I doing this? I think there's a story to be told, and it is also creating content is something I both enjoy, find incredibly scary, and it's part of like a personal development thing. But what I focused on, or what I try to focus on, is why have I done something, and then the next thing is to explain it in terms I think most people can sit along and listen to. So, I try to think, say a Formula One fan who isn't an engineer could sit down and get something out of the video. So I try and, keep it a discussion around trade-offs in a lot of ways and ways to think about things and analogies. I do it for the most part unscripted. I've tried scripting parts of it and it's a disaster and takes me forever. So I try and do a conscious stream, and I basically just take about half an hour beforehand to think about what I want to say and the things I want to hit and points I want to hit, and then just go and do it. And it's fun. And like
That's
going.
awesome.
So now F1 is a hit, the movie, right? Let's say they're making a movie about Pikes Peak, and who's going to play you? And it can't be Brad Pitt.
So I got two answers here.
Okay.
For comedy value and some visual lookalikes, that would be Nicolas Cage.
Oh,
Yes.
that's dead. Yes.
You don't need a second answer.
100%.
Okay.
Yeah.
Yeah, and then the second answer is also Nicolas Cage. Yeah,
That's perfect.
he's such a great actor.
I love that. Yeah. No, I can see it. That's great. That's a great answer.
Well, Robin, thanks so much, man. Really interesting conversation. This has got to be one of my favorites we've ever done.
This is awesome.
Yeah, I'm our audience is going to love this too. Speaking of audiences, where do people go to find you?
On YouTube, first of all, is at the Sendy Club. That's Sendy. Also on Instagram, that's robin.shute, Shute. That's the best place to follow me. Try to get YouTube videos out every couple of weeks, and Instagram I'll post here and there. So yeah, best place.
Love it.
Awesome. Thanks again, man.
Yeah, thank you so much, Robin. This has been a blast.
Absolutely, my pleasure. Love this with you guys. Yeah.
Love to hopefully one day see you at Pikes Peak. That would be dream come true. Yeah, that'd be awesome.
Get your butt down there. You should get Autodesk with a little sticker on the side. Sponsorship.
There you go. Yes.
To manage it. There you
All
go.
right, we'll get right on that.
I'm on it, man.
Love that.
Okay, brother. See you later.
Thank you. Bye-bye.
Hey, everyone. Don't forget to like, comment, and subscribe to our YouTube channel to stay up to date with all things Shop Talk. If you're ready to try Fusion 3 yourself, find the link in our description.